Hello everyone. This video is on the Knewton Alta assignment for section 4.7 called Graphing Linear Inequalities. Alright, so in this video I'm going to be going over a preview version of this assignment. Now, I hope you understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same and the structure is similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Now on the assignment page you should be seeing the title, the mastery bar telling you how far along you've gotten, the objectives. It looks like there are 3 objectives in this assignment. Under the current objective, you should have a question related to that objective. And then at the bottom of every question, there should be a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. Alright, this is for instructors only. But you will have a more instruction button. Alright, so if you're struggling with a topic or a question, click on this button and it'll take you to a page with some further reading or videos to study. And then you'll be given some questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright, so the first objective I'm looking at is verify solutions to an inequality in 2 variables. So this is just like verifying a solution of an equation with two variables. You'll be given an ordered pair and asked, does it satisfy the inequality? Does it make the inequality a true statement? Alright, so that's all I'm going to be doing in this first one here. Is this, we're given an inequality, x plus y is less than negative 5. Notice it's just is less than, not is less than or equal to. And then I'll go through each of these ordered pairs here. Notice it says select all that apply, and just select the ones that actually make this a true statement. And we'll talk about graphing these inequalities, in a later problem. So x plus y is less than negative 5. Alright, so the first one is, the ordered pair negative 4, negative 8. Let's see. Replace x with negative 4 plus, and then replace y with negative 8, and see if that makes the left side less than negative 5. Well, negative 4 plus negative 8 is negative 12. Is that less than negative 5? Yes. Yes, it is, right? I remember a number line. Negative 12 is less than negative 5. So I'm going to circle that one. I'll select that one when we go back to the assignment. The second ordered pair we're given is negative 6, negative 8. So again, I replace x with negative 6, y with negative 8. So that's negative 6 plus negative 8 on the left is less than negative 5 on the right. Negative 6 plus negative 8 is negative 14. And is negative 14 less than negative 5? Yeah. Yes, it is. So I'll also select this ordered pair. Right? And you're going to notice that these are going to have, infinitely many solutions. So we obviously can't list them all, but they're just having us find a few here. The third ordered pair we're given, negative 3, comma, negative 10. Plug in negative 3 for x plus negative 10 for y. Is that less than negative 5? And yes, again, right? Negative 13 is less than negative 5. That is true. So that's another one I'll select. Man, so far so good. the fourth ordered pair, 3, negative 4. So 3 for x plus negative 4 for y. Is that less than negative 5? Well, now, the left side is negative 1. Is negative 1 less than negative 5? Unfortunately, not this time. So I'm not going to select that ordered pair. That is not a solution of this inequality. All right, and then the final one, go over here. The final ordered pair we're given is negative 5 for x, negative 3 for y. Plug negative 5 in for x, plus, and then negative 3 in for y. Is this less than negative 5? Yes. Negative 8 is less than negative 5? Absolutely. So of all these ordered pairs, only one of them wasn't a solution of this inequality. Right? So back on the assignment, I'm selecting all except for the ordered pair 3, negative 4. And it's that simple. This objective verifies solutions should be that simple. You're just plugging in values for x and y and seeing if the inequality is true or not. And then after you submit an answer, it'll tell you if you're correct or incorrect. And then it should give you some sort of answer explanation. Please read through the answer explanations just to make sure that you understand why something was correct or incorrect. And hopefully you can learn from your mistakes for future questions. Alright, so still with this same objective. So again, we're given an inequality. Now this time I'll just speak this one out loud. X plus y is less than 4. Not equal to 4, but just less than 4. So I just basically add up the x and y coordinate and ask, is that less than 4? So 6 plus negative 7, that's negative 1. Is that less than 4? Yes. So that's a solution. Negative 10 plus 7, that's negative 3. Is that less than 4? Yes. So that's a solution. Negative 8 plus 1 is negative 7, which is less than 4. That's true. That's a solution. 0 plus negative 3 is negative 3. Is that less than 4? Yeah. 1 plus negative 5 is negative 4. Is that less than 4? Absolutely. So every single one of these is a solution to the inequality I was given. Every single one of those satisfies the inequality. Again, these should be simple enough. Just plug it in and check it, Alright, now we get into graphing one of these linear inequalities. Alright, how do I graph it on the xy coordinate plane? And you see they got some stuff to move around here and shading to do. I'll show you what all this stuff means when we get back to the assignment. But first I'm going to write out the inequality we're given and then talk about how to graph an inequality. Alright, a linear inequality in two variables on the xy coordinate plane. Alright, so this inequality I'm given, we're asked to graph, right? Now remember, anytime you hear the word graph, it just means draw a picture of the solutions, right? Draw a picture, a representation of all the solutions of the equation or the inequality that you're looking at. So the inequality I have here is negative 3x plus 3y is greater than negative 6. Right. So the first step is going to be graph what's called the boundary line. This is going to be a line that separates the area of the plane that doesn't have solutions from the area that does have solutions. So graph what's called the boundary line. And if you have just a greater than or just a less than symbol like this has, this boundary line will be a dashed line. Make it a dotted line or a dashed line. And if you have greater than or equal to or less than or equal to, then the line's going to be a solid line. Right? And the reason for this is when you have just greater than or just less than, the points on the line are not solutions. So we're going to make it dotted. It's almost like having an open point. You know, these points technically aren't there. They don't belong. They don't satisfy the inequality. But when you have greater than or equal to, less than or equal to, the or equal to part will be satisfied. So the points on the line, the boundary line, will be part of the solution set. So to make it solid, it's like filling in the points. Now the boundary line is simply write the inequality the way it is, but just, make an equal instead of inequality symbol. All right, so this is called the boundary line. Negative 3x plus 3y equals negative 6. Now this is simple enough to graph. Now, you can put this in slope-intercept form if you want, but remember when it's in standard form like this, ax plus by equals c, it's pretty easy to find the intercepts. Right, like if x were 0, y would have to be negative 2. Right, so 0, negative 2 is on the graph of this boundary line. And if y were 0, x would be positive 2. So 2, 0 is on the boundary line. And then like I said a second ago, since there's just a greater than symbol, these points don't actually satisfy the inequality, right? These points on the line make the left side equal negative 6, not greater than negative 6. So that's why we're going to make a dotted line or a dashed line here. All right, so this is going to be a dashed line, meaning that the points on this boundary line are not solutions. All right, that's why it's dashed. That's why it's dotted. Okay. Now, this line, like I mentioned a minute ago, this line I just drew separates the plane into two regions. There's everything on one side of the line and then everything on the other side of the line. One of these two sides is going to have all the solutions to the inequality, and then the other side will have no solutions. Right? So then we're just going to pick a point, pick and test a point that's not on the boundary line. So for this example, here's the origin. Usually, now if the origin's on the boundary line, I can't use it. But here's 0, 0, How about 0, 0? Let's test this out, see if it's a solution or not. So we have, plug in 0 for x, 0 for y, see if it makes the inequality true. Negative 3 times 0 plus 3 times 0, is that greater than negative 6? Well, the left side is just 0. Is that greater than negative 6? Yes, that's true. So that means the side with this point has all the solutions. And the side opposite that boundary line, the side opposite that doesn't have that point, has no solutions. So the solutions to this inequality, and this is where I'm going to do the shading, the side with 0, 0 on it, I'm going to do shading. This side has all the solutions, this side of that boundary line, and the other side has no solutions. Right? So here are the solutions of this inequality. Right? So you pick any point over here, and it would satisfy the inequality. It would make it true. The points that don't make it true are the points on the line, right? Like 0, negative 2, 2, 0. Those don't make it. Those make it, the left side equal negative 6, not greater. And then all the points below it, all the points over here in the blank spot, pick any point over here and it won't satisfy the inequality either, right? So yeah, it's pretty simple. You graph this boundary line and just replace the inequality symbol with equals. Graph that line and make it dashed if it's less than or greater than. Make it solid if it's less than or equal to, greater than or equal to, right? Because the equal to part will be satisfied by the line. Then after you have the boundary line in, you pick a point on either side and see if you have a solution or not. If the point is a solution, then that side has all the solutions. If the point wasn't a solution, then the other side has all the solutions. It's really that easy. Right, I feel it's simple enough. All right, so now I want to make a picture like this in the assignment. They have you moving some stuff around. So move some points, right? We said, on the boundary line here, 0, -2 is on the boundary line, and 2, 0. All right, just make sure I got the labels right. And I want this to be solid. I want this to be a dashed line, and I want everything above it shaded. Right, so that looks like this part right here. Right, so I move this dot down to this area like that. See where it's a dashed line, a dotted line, right? Meaning the points on the line are not solutions. And then the side that had 0, 0 on it, this side up here, the shaded area, these are all the solutions, all the ordered pairs that satisfy this inequality. All right. And then I'll submit. Great. Now, if you'd also like to really double check it, you can go to the Desmos website, desmos.com. It's a free online graphing calculator. And the nice thing about this is you can enter inequalities, linear inequalities, and it will do the graphing like I just showed you. -3x plus 3y is greater than -6. And you see the dashed line here with the 2, 0, 0, -2 are the intercepts on that dashed line, and everything above it shaded. You can enter these inequalities as they look in this Desmos site, and it'll show you what they look like. All right, give you the graph, a picture of all the solutions, where all the solutions are. So it's real nice. All right. Next. All right, so another one where we're asked to graph one of these linear inequalities, right? Draw another picture where you're pointing out where all the solutions of the inequality are. All right, so once again, I'll write this out on a piece of paper, and we'll go through it. All right, so this inequality, x plus 2y is less than or equal to this time, right? So that means the boundary line points are going to be solutions. So I'll make it solid. And then the other side is -2. So yeah, first the boundary line x plus 2y equals -2, and this is going to be solid. I'm going to make it a solid line. Now once again, you can put this equation into slope-intercept form if you like, but it's easy to say what the intercepts are again here. So if x were 0, y would have to be -1, right? So 0, -1 is on this boundary line. And then if y were 0, x would be -2. Right? So -2, 0 is on this boundary line. And again, the boundary line is solid. Right? All the points that are on the line are actually going to be solutions of the inequality, right? They satisfy the equal part. All right, now what about the points that satisfy the less than part? Right, where are those? Well, remember, you just pick a point on either side. Now again, it doesn't have to be the origin. But if the origin's not on it, that's a nice point. So how about the point 0, 0? All right, so I'm going to test a point. Again, test a point not on the boundary. If the origin is on the boundary line, you can't use it. Now if I put in 0 for x and 0 for y, the left side is 0, is less than or equal to -2, that's false. 0 is not less than -2 or equal to -2, it's greater than -2. So the side with 0, 0, right, this side up here where my thumb's shaking, the side above the line, that does not have solutions. All those points make it false. So that means the side opposite that, these points here, make it true. All right, here's where the solutions are. The side opposite that side with 0, 0. There you go. And again, you can go to that Desmos site, which I will for a lot of these. I'll enter the inequality as it looked, right? It was x plus 2y is less than or equal to, and it just -2. And you see it's a solid boundary line. Has 0, -1 y-intercept, negative 2, 0, x-intercept like in my drawing, and shaded below. Right? All, the origin is not a solution, but all these points over on this side of the line are. And then in the assignment, right, we just move points around. Like I said, just move these 2 points to 2 points on the line. We saw one of them was at negative 2, 0. Just make sure, click on it and make sure it's at the right spot. The other one was at 0, negative 1. And again, just click on it, make sure it's at the right spot. And then I want a solid line shaded below. That looks like this box here. Let's move this dot here to this 4th box. And there we go, solid boundary line shaded below, pointing out all the solutions of this inequality. Wonderful. All right. Next. All right, and then recognize the relationship between the solutions of an inequality and its graph. All right, so write the inequality shown by the shaded region in the graph with this bound. Now they give you the boundary line. They give you the boundary line. Now notice that the boundary line is a dotted line, not solid. So the inequality symbol, I'm going to replace this equal sign with a less than or greater than symbol. I just have to figure out which one's which. And then notice that, 0, 0, the origin is below here. Or you could pick, you don't have to pick 0, 0. Just pick some other point that's in the solution region, like negative 5, 0, or whatever. And make sure that that actually is a solution. All right, so I'll draw this one out, this first one, and I think the rest of these will be pretty easy to do without drawing. But all right, so here's this drawing. Right, they say that the boundary line is y equals negative 7/3 times x plus 1, and that that would look like this. It has the 0, 1 is the y-intercept, and then down 7, so to negative 6 here. Down 7, right 3. It would have the point 3, negative 6 on it. And they have drawn a dashed line. Right? It is a dotted line. Like that. That's the boundary line. And all the solutions are below it. Right? All the solutions are below it. So because it's a dashed line, it's going to be either y is greater than negative 7/3 x plus 1, or it's going to be y is less than negative 7/3 x plus 1. And again, just pick a point in the solution area and see which one does it satisfy. So I mean, again, an easy one would be 0, 0. Just pick a solution and see, is 0 greater than 1? If x were 0 and y were 0, you'd have 0 is greater than 1. Nope. So that's not the one. It's got to be this other one then. And if you test it out, pick a solution 0, 0. Is 0 less than 1? Yeah. Right. That works. So it's got to be that second inequality that I had there. All right, so back here I'm putting that in. All right, y is less than negative 7/3 times x plus 1. And of course, you could always double check back on the Desmos site, put in the inequality y, the one I think it is, y is less than negative 7/3 x plus 1, and that does look pretty close. It looks almost exactly like what they have there. It's a dotted line like that, shaded below. That looks pretty good. So it's got to be less than. Great. All right, next. So again, pretty much the same thing here. They give us the equation of the boundary line. All right, they give us the equation of the boundary line. Notice that it is solid. It is not dashed. It's not dotted, meaning that you're going to have greater than or equal to, or less than or equal to, replacing this. And then, we could pick a solution like negative 5, 0. Now notice 0, 0 is not a solution. So I mean, you could see if 0, 0 satisfies it or not. You know, is 0 plus 0 greater than or equal to negative 3? Yes, it is. So it can't be greater than or equal to, because if it were, 0, 0 would be a solution. So it's got to be less than or equal to negative 3. I hope that makes sense. So very simple. 4x plus 3y must be less than or equal to negative 3. That way 0, 0 is not a solution. All right. Or again, now again, you can check by pick a solution, negative 5, 0, and see, oh, if x were negative 5 and y were 0, you'd have negative 20 is less than or equal to negative 3. That's true. All right. So this should be the good one. Yeah. So really for this objective, when you're given a graph like this, you're just trying to figure out what inequality symbol goes where the equal sign goes when I'm on the boundary line. All right. All right, then back to this. Just now again, they're not all this simple, but you're given an inequality, and just ask which of these ordered pairs are solutions. So plug in the x, plug in the y, and is x plus y greater than negative 2? So I'm just adding the x and y coordinate and asking, is it greater than negative 2? 10 plus negative 1 is 9. That's greater than negative 2, so that's a solution. Negative 8 plus 9 is 1, which is greater than negative 2, so that's a solution. Negative 1 plus negative 9 is negative 10, which is not greater than negative 2, so this is not a solution. I'm not selecting it. 6 plus negative 3 is 3, which is greater than negative 2. And 7 plus negative 9 is negative 2. But that's not greater than negative 2. Right? Negative 2 is equal to negative 2, but not greater, so that's not a solution. Wonderful. All right, moving on. All right, so one more of these, and again, like I say in the beginning, the questions I see here may not be the same questions you see, so they're not always going to be x plus y is greater than something or less than something. All right, they might have a different look to it. But here you're just taking the x coordinate and adding the y coordinate and then asking, is that less than 3? All right. 2 plus 0 is 2, that's less than 3. Negative 6 plus 0 is negative 6, which is less than 3. 7 plus 5 is 12, which is not less than 3. 3 plus negative 3 is 0, which is less than 3. And negative 10 plus 0 is negative 10, which is less than 3. So the 4 ones I selected are solutions of that inequality. All right, so again, that should be the easiest of the objectives, I think. I don't know, the one with the graph and the one where they give you the graph is pretty simple too. Yeah, this one here, recognize relationships. So yeah, you just take the boundary line equation and you just got to figure out, what inequality symbol am I replacing the equal sign with. So it's a solid line boundary. So this has got to be greater than or equal to or less than or equal to. The origin is not a solution. The origin is always a good point to use, when it's not on the boundary, which it's not here. The origin is not a solution. So is 0 greater than or equal to negative 1? Yes. If you put in 0 for x, 0 for y. So it's not greater than or equal to, because the origin would be a solution then. So it's got to be less than or equal to. Y is less than or equal to that stuff. And again, you can go to Desmos and plug that in and verify it. Y is less than or equal to, and the other side was negative 8/3 x minus 1. Right. And then just one more of these. Again, we have another solid boundary. So this has got to be greater than or equal to, less than or equal to. This time the origin is, again, not on the boundary. If the origin is on the boundary, you have to pick another point. All right. But the origin, again, is not on the boundary, and it is a solution this time. So if I plug in 0 for x, 0 for y, you'd have 0 on the left, negative 6 on the right. Is 0 greater than or equal to negative 6? Yes. So it's got to be greater than or equal to, right? We want the origin to be a solution. So the inequality is 2x plus 2y is greater than or equal to negative 6. And again, you can graph that in Desmos or by hand and see that, works out. Same picture. All right, and then the final couple will be on graphing again. All right, so again, I'll do this by hand first. You can go to Desmos if you want, but I'll show you by hand. All right, so here the inequality we're given, negative 4x plus y is greater than or equal to 8. All right, so the boundary line, all right, the line that's going to separate solutions, the area with solutions from the area without solutions, is going to be negative 4x plus y equals 8. And since this is greater than or equal to, the points on this line will satisfy the inequality. So I'm going to make this a solid line, right? Now, you can get this in slope-intercept form if you want, but once again, it's in a form where I can easily state the intercepts. If x were 0, y would be 8. Right, so 0, 8 is on this thing. And if y were 0, x would have to be negative 2. So negative 2, 0 is the x-intercept. 0, 8 is the y-intercept. It's a solid line. There's the boundary. And then you pick a point that's not on the boundary, and then once again the origin is an easy one. So if I test 0, 0, again, it doesn't have to be 0, 0, right? You can pick any point that's not on the boundary, but usually the origin's pretty easy. The left side will be 0. Is that greater than or equal to 8? No. 0 is less than 8. So the side with the origin is not the side with the solutions. All right, it's the other side, the side above the line. All right, and there's your picture. All right, so back on the assignment, all right, moving the points around. Again, the intercepts are negative 2, 0, 0, 8. Just click on them, make sure I got them in the right spots. And then I want a solid line with the shading above it. That looks like this fourth box here. Great. All right, and then there should be one more of these. So negative x plus y is greater than 1. All right, so the boundary will be negative x plus y equals 1, but it will be a dotted line. Now, if you were graphing that, if x were 0, y would be 1. And if y were 0, x would have to be negative 1. So you got negative 1, 0 is the x-intercept of that line. 0, 1 is the y-intercept of that line, just making sure I got them right. And it would be a dashed line. And then if you plug in the origin, is 0 greater than 1? No. So the side with the origin won't have solutions. It'll be the side above. So it'll be a dashed line shaded above. That looks like this last box on the bottom here. And there we go. And again, you can draw it by hand if you wish, or look at Desmos. Great. Alright, then that should be it for this preview version of this assignment. Like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same. The structure should be similar. So I'm hoping that watching me do these here helps you in some way when you're working on the assignment on your own. And thank you very much for watching.